In this video, you and I are going to take a look at security for devices and systems that, once in place, don't change all that much. Let's begin. Many times we're going to have systems that are purpose built. For example, they do one specific set of things. An example of that is a SCADA system. Now, SCADA stands for Supervisory Control and Data Acquisition. I've also seen it referred to as System Control and Data Acquisition. And an example where we would often find SCADA being used would be in the collection and processing of energy, such as natural gas or oil, or the management of electrical power. And a SCADA system is going to be made up of hardware and software. The hardware is going to gather the information that's happening at their respective locations and feed that or forward that into a system that is running SCADA software. For example, this device right here. And then that data can be used to control the equipment and the conditions that are currently happening. For example, do we need valves to be opened or valves to be closed? Is there enough pressure at certain points in the system? And normally SCADA systems are pretty large in nature. Maybe a huge company with multiple sites, and they use a SCADA system to get that information and to manage it all. Now in a smaller environment, we might have a SCADA system as well for managing our doors and air conditioning and so forth for an entire building. And so we could have hardware at specific places that are gathering the information, feeding it to a centralized device that can process it, and then act on that data. The folks at energy.gov wrote a document that's 21 steps to improve cybersecurity of SCADA networks. And some of the results will absolutely not be surprising to you. Just like in a local area network where we want to know who's connecting to our network, in a SCADA system we would also want to clearly identify exactly who is connecting. And if there's anybody who's connecting who shouldn't be, simply disconnect those nodes from the network. We want to harden the SCADA network by removing or disabling unnecessary services. Make sure we're being careful about any backdoors into the SCADA system. We want to make sure everybody who's on that system is going through the proper authentication, authorization, and permissions control before they make any changes to that system. We want to have intrusion detection and monitoring services. We want to do periodic audits of those devices. We want to have an incident handling team that can address any incidents that do come up regarding the security of the SCADA network and systems. Now, regarding Security Plus, we absolutely do not have to be an expert on securing a SCADA system, but what we should be able to do is apply our best practices that we've learned throughout this course to a system like SCADA. So, for example, if we have SCADA connected to a local area network, and let's say on this port we have Bob, and on this port we have Lois, and this port we have Lewis, and this port we have Jim. And let's imagine that these four users are simply users of the computer network. They're not specifically tied into SCADA. So what we could do is put those users in their own VLAN, or more specifically, we could create a separate virtual local area network just for SCADA and have our SCADA devices connected on that protected and private VLAN. So our end users, who are just like surfing the internet and using the network for general purpose needs, we want to make sure those users are not in the same VLANs and not in the same IP subnetworks as our SCADA devices. So by implementing VLANs for network separation is one of the methods that we can use to help improve the security of our SCADA system. And we can take it one step further. Let's say for the SCADA network it's VLAN 25. We could also control what VLAN 25 and its associated IP subnet, what it's allowed to reach. So by using access control list on routers and or firewalls, we can limit what access the outside world has to this SCADA network or SCADA system, and vice versa. We can also limit what access the SCADA network or system has to the outside world or to other networks. And regarding other special purpose devices like printers that have network capabilities or smart TVs or HVAC systems, if we were concerned about the security of these devices, one of our big first steps would be to place all of them on a special VLAN that has limited access. So maybe we have a management PC that runs software that can control these devices, and this management PC does have access to the VLAN and to the subnet where these devices are, but the rest of the world, like Joe and Billy and Kim, their devices would not be given access to the control aspects of these devices. Now there may be some mixed requirements. Maybe Joe, for example, does need access to a printer because he wants to print, but at the same time he doesn't need access to the smart TV and the HVAC control. While Kim, on the other hand, she is in charge of managing the HVAC control, but she doesn't need access to the smart TV or the printer. Once we've set up our VLAN separation, maybe one for the printer, one for the TV, and one for the HVAC controls. So these all represent individual VLANs. And maybe this is VLAN 10, and this is VLAN 20, and this is VLAN 30. What we could do is tie all those together either with a router or a firewall that has the ability to route between those, and then we can set up access control based on the user. So once Joe, Billy, and Kim have all authenticated, the firewall can control exactly who is allowed to go to the printer VLAN and those devices, or to the TV VLAN, or to the HVAC VLAN, if that's how we have them separated out. We could also have software controls in these devices, for example, the printer or the TV or the HVAC, that specifically identifies which source IP addresses are allowed to connect. And secondly, if somebody does connect, specific user accounts that are allowed to manage or manipulate those devices. And those are all referring to forms of access control. And the acronym of ACL refers to an access control list, or a list, if you will, of individuals or addresses or systems that are allowed access. Hence the access control list. And this term can be used generically, referring to access controls. It's also often referred to a specific list of permit or deny statements that may be on a firewall or a router to implement the access controls. In an environment where we have handheld or mobile devices like Android and iOS, referring to Apple's iOS, we would want to use best practices regarding mobile devices that we've talked about in previous nuggets, including disabling services or applications that are not needed on those devices, using techniques like access control, requiring authentication before anyone can log in and use those devices, and turning off services like Bluetooth or wireless if we're not using those services. Any services that we can turn off is going to reduce the attack vector for that device. Another aspect regarding network connectivity for mobile devices is that if we're using some hostile or untrusted wireless network, first of all, we should consider not using it. But if we have to use it, we might want to build a virtual private network from that Android or iOS device through the network to a gateway or a firewall or a VPN server that we trust, and that can encrypt and protect that entire segment of our journey, including over the untrusted or unknown wireless network that we happen to be using. I still remember back in the 1980s when I was introduced and shown for the very first time, for me anyway, what a mainframe looked like. And there was lots of cabinets like these. And there was a couple of locked doors to had to get through to go ahead and see them. It was all humidity and temperature controlled. And we have come a long way since then. And from a system and network perspective, a mainframe is a fairly static environment. I mean, we know where the CPUs are. We know where the terminals are. And one thing that happened in the late 80s and early 90s is that instead of using dumb terminals, we started to use PCs that were connected to local area networks, and then we'd have the local area networks connected to the mainframes. And it wouldn't be a direct connection. There were some front-end processors, and there were some other intermediate devices to allow that to happen. And regarding securing that type of an environment, we'd want to make sure that we had our routers and firewalls that were controlling what traffic was allowed between, for example, the local area network and the segments of our network where we were taking the commands for the mainframe and feeding them back and forth. And that would also include setting up multiple VLANs. Again, separation of networks with access control between those networks. Other environments that we well may want to protect and protect against are things like game consoles. I mean, think about it. If this PS3 or whatever game console you want to use is connected to a network, traffic goes both ways. It goes from the internet to this console and from this console to the internet via wireless. And on many systems, there's also Bluetooth capabilities as well as cameras that are attached to the gaming system. So we may want to consider network isolation for those as well. Create a separate VLAN, or if we're connected wirelessly, a separate wireless local area network, and have some separation between this device and the other computing devices that may currently be on the same network. And the cameras that are attached to these systems, we may want to consider putting some type of cover over those cameras so that if compromised, our gaming console isn't a 24/7 access method of an attacker seeing exactly what's going on within the vision of an attached camera. And most vehicles today have some type of in-vehicle computing system, whether it's for navigation or communication, which also could be leveraged by the wrong hands. So in any system that we have, we just need to be aware of the potential of a security risk regarding this system. So what are some methods that we can use in measurable terms to help improve our security posture with any of these environments? The first on our list is network segmentation, putting devices in separate networks and then using access control mechanisms to filter or stop or control the traffic that's allowed between those two VLANs or two networks. Having multiple layers of security is a great idea. That's the concept of defense in depth. An example would be that when we start up a device, let's say it's a game console, for example, before it's allowed to communicate in or out of the network, a secondary password or passphrase is also required. In addition to routers or firewalls identifying and allowing certain types of traffic between two different networks, we could also have an application-aware firewall looking at the application data just to validate that this is the right type of data that's allowed to go between the two different networks. So if someone is masquerading or hiding behind, let's say, for example, port 80, when the actual payload is something very, very different, maybe an attacker is leaking data out of your network, making it look like HTTP, but behind the scenes, it's not HTTP traffic. An application firewall could identify that, which would be considered malicious behavior, and stop that traffic from being forwarded. Another item that can cause us grief in these environments are automatic updates. Now, automatic updates they're good in a sense that they can help keep us up to date. However, what if there is an update of some type that causes a vulnerability or a weakness to be exposed on your system? Or what if the attacker can trick the device into thinking there's an update, having your device automatically process the update, and now the vulnerability, the malware, is running and the attacker can take advantage of it? So by doing manual updates after you've verified exactly what's going to happen and the behavior of your applications after the update is done, that's another method we can use to help securely do updates in our environment. And the same is true for firmware. Many of these devices are going to have firmware that they use in combination with the software that they're running. And if there are any firmware updates, especially if they're addressing some security vulnerability, we'd want to first of all test that firmware update to verify that the upgrade will actually work correctly and not cause a worse vulnerability from a security perspective, and then using change management control, implement the firmware updates. Now, the concept of a wrapper could be a couple of different things. Number one, if we had a SCADA environment and we had a PC running the SCADA software and it was controlling all of these devices across a large network, pump sensors, flow control valves, and a whole bunch of other items that it was getting information for and controlling, the communication right here between this control PC and the actual units that are being controlled, and if we use a TCP wrapper for the segments that are sent back and forth between these two devices, and the wrapper can provide an extra layer of security by intercepting calls and determining whether the service is authorized to execute or not. So that would be one example of wrappers as a TCP wrapper. Another example of a wrapper of sorts would be using TLS or SSL for secure communications between the SCADA control unit and the node or device that it's communicating with. In either case, we're using wrappers to help mitigate against an unauthorized individual acting as an imposter and trying to communicate with one of our devices. Because if the device receives a command or a request, and the device doesn't trust the request because it's not part of the TLS/SSL session, or because the TCP wrapper information doesn't match up regarding a permitted request or action, it'll stop the request or action from the unauthorized individual from proceeding. Now, I've got a question for you. Let's say that this SCADA host right here is receiving information from these four devices regarding the pump control function at that location. And then based on the information that we're getting, the SCADA host could send requirements regarding changing various parameters. Maybe to slow it down or speed it up, change the pressure in some pipe or what have you. Now, my question is this: what would happen in the event we lost that communications path between the SCADA host and these nodes in the SCADA network? Obviously, we're not going to be able to get information, and we're not going to be able to set parameters or make changes via the SCADA host right here if it can't reach those devices. And that is why we'd want to make sure we have redundancy and diversity regarding our control systems. Now, redundancy refers to having more than one, a backup plan, an alternate method, for example. And diversity refers to using some different method than the first one. For example, let's say the SCADA host is connected to the internet, and the internet is connected to those SCADA nodes, and that's how we're communicating through the internet. And maybe we're going in through service provider A. Well, an example of what not to do is to purchase a second connection also from service provider A using the same methodology to control those devices. Because if service provider A fails, we now have a single point of failure. So for redundancy's sake, maybe we're using service provider A as our primary method of managing those devices. And then as an alternate method, maybe we're using the public switch telephone network, which isn't real fast, but it's really reliable, as a backup method to go ahead and get information from these SCADA nodes and have it fed back to us, as well as send control messages to those devices. And it would also probably be a good idea not to use the same service provider for the internet access as we are for the PSTN, because we want the diversity. We want different methods, and redundant methods. So at the end of the day, if there's some problem with one path of managing our devices or getting information from those devices, we have a backup plan. We have a plan B in place that can work and still allow us communications with those critical devices. I've had a great time, and I'm glad that you joined me for this video. I hope this has been informative for you, and I'd like to thank you for viewing.